Hello everyone, welcome to another episode of C++ programming. In this episode, we are going to explore multithreading with C++ with GCC compiler on macOS operating system. Let us get started. First of all, let us get familiar with the environment that we are going to use. We are going to use the Mac operating system by Apple, and you can run all the programs that we are going to demonstrate on any Unix like operating system as well as Windows operating system if you are going to use the GCC compiler. So I have already created other episodes on installation of GCC compiler on all the operating systems, and you can find the link to all those episodes in the description down below. Now we are going to understand the environment. Basically, we are going to use the command prompt of Mac OS, and the terminal emulator is the command prompt of the Mac OS. And let us get familiar with the compiler things. So there is CC compiler and we can check the version. So here we have Apple LLVM version 10.0.0. Similarly, if I check for the C++ compiler and say version, it also says Apple LLVM version 10.0.0. Now let us check for the GCC compiler, which is GNU compiler collection and version. Okay, so I think that it is a different compiler, and G++, it also must be linked to GNU compiler. Okay, so G++ is linked to GNU compiler, and we are going to see the usage of both the compilers. Now let us go to the documents directory and let us go to my directory in that, and let us create our own directory mkdir cpp multi-threading. Okay, so cd cpp. Now all the code that we are going to write here will be available for download, and I have already uploaded that on the GitHub repository, and you can find the link to that GitHub repository in the description section of this episode down below. Now we have choices of various IDEs. So the very first and the simple most IDE that we are going to use for a simple program is Nano. It is not even an IDE. Basically, it is a text editor. It's a command line based text editor, and it uses primitive text based graphics. So let us write a simple script in C++. So let us say hash include iostream and int main and std cout hello world. And in the end we are going to say return 0. And let us save this program. Now first of all we are going to try the C++ compiler, the LLVM compiler, C++ hyphen WALL hyphen std equals to C++ 20 proc00.cpp. Okay, so I guess we have made some small mistake. It should be GNU ++ 2a. Okay, so I'm going to say GNU ++ 2a, and it should compile the program without any issues. Okay, so I think that we have made a small mistake, and here we are going to rectify that mistake, and let us save the program. Let's clear the console and let us compile that program again. C++ hyphen WALL, where W is in uppercase, hyphen std gnu ++2a prog00.cpp, and it has compiled successfully, and it must have generated a.out file. Yes, we have a.out file, and let us go ahead and execute this file and let us see what the output is. Yes, here we can see the output hello world. Now let us compile this program using G++ compiler. Okay, so we are also able to compile the program with G++ compiler, and let us execute that a.out, and here we have the output hello world. Now we have another choice of IDE. I have already installed the Genie IDE, and here we can find the Genie in the options. So this Genie is a very versatile IDE. I have already created another episode on installation of GCC compiler on all the platforms, and I have also mentioned there how to install Genie on a Mac OS. So it will be great if you could go ahead and check for that video on my YouTube channel. So now I can go ahead and open already existing file, and let us go to the home directory, and in the home directory, or let us check the documents Ashwin data, and here the cpp underscore multi, and here we have program 00.cpp. So let us increase the size of font. For that I am pressing the control key and scrolling the mouse wheel. I am scrolling down the mouse wheel to be very specific, and we have here build option. We can compile the current program, and it says compilation finished successfully. Now if I click this gear symbol, it should be able to run this program. Okay, now it is saying that no such file or directory. So we are just going to close it because it is not able to run the program, though it is able to compile it. So I have found this problem with Genie in many operating systems. So we are going to try the Xcode IDE. So let us go ahead and force quit the Genie. Quit. Okay, so we are going to open another project. So basically, let us go to the documents, Ashwin data. Here we have cpp mult, and in that we have prog00.cpp. So I'm going to open that file in Xcode IDE. And there should be option to run this program, but I don't see the option to run. So as of now, what we are going to do, we will close this and we will again open this thing, and I'm going to choose get started with a playground, and we are supposed to choose the template macOS. Next, or let us cancel this. Let us again double click and let us create a new Xcode project, and let us choose the macOS and command line tool. Next, let's mention the project name cpp underscore mult, and it is going to be a C++ project. I'll choose next, and here in Ashwin data cpp mult, and in this directory I'm going to create that particular project. Now here we have the main.cpp, and we can build it and run it with the options given in this. Okay, so let us see how we can build it. So here we have the option to build and then run the current scheme. So it says build successful, and it should actually launch the file for execution. Okay, so I will say add build successful, and let us see where is the option for, yeah, so here we have the option for the executed program. So similarly we will delete this file and move to trash, and here in the C++ create a new file. Okay, so it is going to be a C++ file, and let us go ahead and click next, and let us uncheck this. Name will be prog01.cpp. So I guess I made a spelling mistake. Okay, so this is going to be our file, and yeah, in cpp mult created. Yeah, here we have the file for our multi-threaded program. Now we are going to write a very simple multi-threaded program with this file, and it's a cpp file, right? So I'm going to say here IO stream. Next thing I'm going to say hash include thread. So this is the very first time I'm trying thread programming on macOS with C++. So it will actually take some time if I get stuck. So please bear with me that. And let us write a simple function. And in that function, we are going to say std cout and semicolon /n inside the routine foo. And let me copy this. Let us paste this entire stuff in a new line, and we can change the name and the definition also. We can also input an integer, and we can say x. Okay, so we are going to print the value of whatever we are passing as an argument. So these are two simple functions. Now let us see how to create threads and how to call these functions using the threads. So basically, whenever we are going to create a thread in C++, it is going to call, it is basically going to be associated with a function, and it is going to call that function while executing, and it is going to execute the code in that function. So it is going to be very interesting. So let us write the main function here, main home int main. Okay, sorry, I'll say int main, and in that we are going to say return 0. So this is very first time we are writing this code, that is why it is taking so much of time. So from the next program onwards, we are just going to copy and paste the code that we have already written. Now I will say std thread first and foo. So this is how we can create a thread, and see here we are creating a thread variable, and then we are passing the name of the function to be associated with that thread. Now this is a function without an argument. Now we are going to pass the second thread a function with an argument, and you see how I do it. Just say bar comma 0. So this is how we can pass a function with argument to the thread variable. Okay, so I will say second. Basically, first and second, these are the names of the threads. I will say std cout, and I will say inside main. Okay, it is saying that expected expressions. Okay, the error is gone. Now let us synchronize both the threads. So first dot join, and second dot finally we will say std cout completed executing foo and bar. Also I am going to print std cout, and let me copy this much of code, copy and paste it here, and here in place of foo I will just say main. So this is a simple program with two threads. So the first thread is calling a function without any argument, and the second thread is calling a function with a single argument. So here we have to mention the name of the function and then all the arguments that we are supposed to pass to that particular function. Now let us save this file save, and let me go ahead and build this file. So it is now building the file and it says build succeeded. Cool. Here we can see the output. Okay, and I think that we should add /n everywhere so that the output will be more clear to all of us. It will be more readable. So now I am going to follow that convention from now onwards in every program. So let me save that file again and let us go ahead and execute it again. So it is building it again, and here we can see the build is successful. Okay, and in the last one also we will add a /n. Again I will save it, again I will execute it so that it is more readable when it displays the output. So it is automatically compiling and executing our thread related code. So this is very cool because otherwise we will have to compile our code manually. Now let me also tell you how we can compile the code manually. So let me clear it, and we can say cat prog 00 or 01 dot cpp. Okay, it doesn't have any such file or directory. I will go to cpp underscore mult. Let's clear it and let us see the number of files. So here we have cpp underscore mult again. Let us go to the cpp mult and ls. Yes, here we have prog1.cpp. Let us clear it and let us see the program. Okay, so here we have the entire program, and we are going to now manually compile and execute this program, and that is also going to be a very challenging thing. So we will say g++ and -wall hyphen pthread. So this is to tell the compiler that we are using POSIX threads with C++, and -std equals to GNU C++, or let us say C++ 20 and prog01.cpp. Okay, so GNU++ 2a is what we are supposed to use. Let us say GNU++ 2a, and if I hit enter, it is going to compile that program manually, and then we are going to run that a.out file, and here we have the output. But this is kind of tedious to compile all the program manually, so I am going to close this terminal window, and we are going to continue working the Xcode IDE in the macOS. So it is very convenient, and I am going to delete all the unnecessary part in this code. Okay, so let me go ahead and save the file. We can also create a copy of that file. I will just say duplicate, and I will say prog02.cpp. Okay, so here we have, okay, sorry, let me delete the file, remove reference, and let us duplicate this file. Okay, file, duplicate, cpp, prog02.cpp. So now we have a copy of this entire file, which is named as prog02.cpp. And the second example that we are going to see is the lambda expression. And we are going to create a thread out of a lambda expression. And that is going to be very, very interesting exercise. So let us define a lambda expression. So I hope that you are comfortable with the concepts in the object-oriented programming and C++. Otherwise, you are going to find this entire exercise very, very difficult to understand, especially the things like lambda and classes and object. You should be very comfortable with all these things. Okay, so this is the lambda expression, and we are supposed to add a semicolon after this, and it is going to show us error. So ignore those errors. As of now, we are going to rectify everything. So std cout and /n inside lambda expression, and let us display the value of x, and let's close this. So I think that we are cool with the function, and let me go ahead and save it. Now we have to make the changes to the main function, and let us close everything. Okay, we will delete this, and we will delete this thing too. Okay, because these two messages are unnecessary, and also this one is also unnecessary. So now here we are going to call that particular lambda thing f comma 0, and it is very, very easy thing. Now let me go ahead and remove the unnecessary spaces. So this is only what, 5 line of program, 5 lines of program. That is cool actually. So let's save it. Let's build and execute it. Meanwhile, I will take a sip of water. Let it execute that thing. Seems like it has built it but not executed it. Okay, it is saying that build failed. So I'm not sure why it is saying build failed. Okay, it says there is some problem, and let us highlight it and let us try to build it. So it is still saying that the build failed. So I have no idea why it is saying that the build failed. Now the only option that is left with us is to manually compile the program. So what we will do, we will write the program in this IDE, and then we will manually compile and execute that program. So I think that it is going to bring the best of both the worlds for us. CD documents, CD Ashwin data, CD cpp mult ls, CD cpp mult, ls cd cpp mult and ls. Yes, we have here all the files, and we will remove the .cp, this file. It is unnecessary. So this is the terminal, and we are in that directory where we have stored the program, and here we can see all the programs. Okay, so in case you want to see the programs, type in ls, and here we have both the programs. Now let us use the G++ compiler. So let us compile it ourselves again. -wall and -std equals to gnu ++2a and -pthread, and let us provide the name of the program 02.cpp. Let it compile. So it compiled the program, and I'm going to say a.out, and here we have the output. It says inside main and then inside the lambda expression. So it is creating two threads, one for the main process and another for the lambda expression, and it says completed executing main, and then it is printing the command prompt in the next line. So this is how we can create a lambda expression, and then we can create a thread using that lambda expression. So let us see the next example of the multi-threaded programming. I have made a copy of our program 2 and named it as program3.cpp. And since we have had a little bit of change in plan, that we are going to compile and execute our programs on command line, I have installed a new command line emulator or terminal emulator for Mac operating system. So it is known as iTerm2, and it is more convenient than the built-in terminal emulator. So now we are going to continue by using this Xcode to write our code, and then we are going to compile it manually and execute it on the command line. So earlier we saw the lambda stuff. Now we are going to see how to create a callable object. So let us define a class thread underscore obj and public void operator int x, and okay, and here we are going to add another curly bracket. So here within this void operator, we have to write a simple for loop for int I equals to 0, I is less than x, I plus plus, and so I will just say callable object dot dot dot. See, basically this callable object is going to take an argument, and it is going to execute that loop for a number of times equals to that argument, and then it is going to display a simple message. Now here we are going to use the thread object underscore obj, and we are going to say 3. So I think that there shouldn't be any problem with the program. Let us save it and let us see how it works. So here we have the iTerm terminal emulator for macOS. Now let me go ahead and compile the program our usual way. G++ or C++ -wall -std equals to GNU plus plus 2A and the name of program prog03.cpp. Let's compile it, and it compiled successfully. Let us try to execute it. A.out, and here we have the object. Okay, so this is how we can execute it, and it is going to create a main thread and another thread for callable object. So it is very simple. I hope that you are able to see whatever is printed on terminal. Else I will go to the preferences and increase the size of font. So let me check how I can increase the size of font. Yeah, here we can increase the size of fonts. So here I have it 50. I am going to make it 50. Okay. So let us save this file and let us duplicate it, calling it prog04.cpp. Now let us see the usage of function detach. Now let us write our foo function again. So void foo. So std cout and /n inside foo. So in main we have to pass it foo, and anyway foo is not accepting any argument, so that is cool. Now let us use the method detach. So this is going to detach this particular thread from the main process, and it is going to create a daemon in the operating system for this particular thread. And here we can check if first dot joinable, then only join. So let me introduce a simple tab here. Okay, so here we have completed executed main and std cout completed executing foo. So let us go ahead and save it. So basically, let me repeat again. This detach is going to detach this thread from this main process, and it is going to create a daemon process in the operating system. So let us go ahead and compile it. Okay, so it is saying that there is no file as prog04.cpp. Oh, I guess I have overwritten the file, is it? I'm not sure why it is not showing us the file. Okay, so I think that I saved it in the wrong directory. Let me go to the documents, Ashwin data, cpp mult, and here I'm going to save it as prog04.cpp. So my experience with macOS is limited. I have recently acquired this second-hand macOS, and let us delete this original file and remove references. So I was saying that I recently have acquired this macOS, and it is a second-hand machine. I bought it from a store that specialized in refurbishing the pre-owned Mac OSs, and I really wanted to have some experience of programming with this Mac OS. That is why I bought it, and now I'm using it to record the videos. So let me clear the screen and run the earlier command. The command executed successfully. It means that the a.out must be available, and here we have the output. So here we can see the output is a bit jumbled because the operating system is running the threads in parallel, and whenever it runs the stuff in parallel, there is really no way any tool can show the proper way that two parallel processes or threads are running, because this command line is serial thing and it cannot actually show us the multi-threaded nature of our applications. So basically any of the messages can be printed earlier or later depending on how operating system is handling those threads. Now let us move on to the next program. Now let us see how we can copy a process or a thread. So let me create a duplicate, and yes, I think that I will have to browse every time for that directory, but it shouldn't take much time. So 5, and here we are going to have cpp proc5.cpp. Now we will simply create another process or another thread by copying it from the okay. So I will have to undo this first. Okay, so here we have the second thread, CCOND, second thread equals to move, and here I'm going to mention the first thread. So this is how we can create a copy of thread using the move function. So this is the easiest way. And now I'm going to delete this detach thing, and I will also delete this particular message because we are running foo twice and it is actually going to print this one. Okay, and let us go ahead and join the second thread. Should we copy and let us say second, and if I save it, let me compile it now. Program 05.cpp, and let us execute it a.out. Okay, so this is the output of this entire program. So let us try to execute it again, and ls-l. We can see here program 5. Let me delete a.out, rm a.out. Let us recompile it, and let me execute this again, a.out. So this is how we can execute it. Now let us move on to the next example. So the next example deals with the thread IDs of the main thread and the child thread. So we will actually understand those concepts through. Before that, we will duplicate our file and duplicate. Let us go to the documents. And CPP. So this program is going to be very simple. I'll delete this line. There will be only one thread in this, and okay, and we will delete this part also. So here we are going to print the process IDs or thread IDs of the main thread and the child thread. So basically this main function, it is going to create a thread in the operating system and it is known as the main thread, and this thread is known as the child thread. So the main thread is also known as parent thread. So we can print the IDs of both the things, std cout main ID, and the syntax for printing the ID of the main thread is this thread get ID /n and std dot cout child ID, and let us see how we can print the child ID. So first dot get underscore ID /n. So this is very simple program. I will save it now and let us go ahead and compile that program. So let me clear the screen. Let's remove the a.out file. Let us compile it. Okay, so we can just say -p thread, and if I compile it, okay, so let me say here prog 06 and it compiled. Let us say a.out and it is printing the ID of the main ID, main thread, as well as the ID of the child thread. So I'm not actually very much familiar how these IDs are assigned by the operating system, because I have already made the versions of the same episode for FreeBSD as well as Windows operating systems, and it seems that every operating system has got its own unique way of assigning the IDs. So in case you want to check out the Windows version as well as FreeBSD and Linux version, you can check the description section of this episode, and there you will find the URLs to the episodes on my YouTube channel where I am explaining the same thing with Windows operating system as well as Linux and FreeBSD. So let me clear this now. Let us move on to the next example. So in the next example, we are going to check for the hardware level concurrency. Let me take a sip of water. My throat is dry. Okay. So now I am refreshed. And let's duplicate this file. Let us go to the documents, Ashwin data, cpp mult, and let us name it as 7.cpp. And let me save it. Now we are going to delete a lot of code. It will be a very primitive and bare bone program, and we are not actually going to create any thread in that. So here we will just print the number of cores and cout number of threads. So I will actually explain you all these things in a moment. Let me type in the code. Be patient. So let us say std thread hardware underscore concurrency. I hope that the spelling of concurrency is correct. English is not my mother tongue, and even if someone has English as his or her own mother tongue, writing spelling is really difficult. Okay, so this is the code that we have, hardware concurrency. So now let me explain something. Basically, earlier, in the very early days, the processors were only able to handle one process at a time or one main program at a time, and they had a single core. Later on, the processors evolved and the processor started to have multiple cores, and those were physical cores. So from one core, we had dual core. Now we can have even quad core, 8 core, 12 core, 16 core, 24 core processors that are commercially available. And every code is able to handle one process at a time concurrently. Okay. So suppose you have 8 cores, then the CPU can handle 8 processes concurrently. Now there is something known as multithreading and hyperthreading. It means that the CPU is also able to handle not only processes but the threads concurrently. So nowadays the processors come with this specification like 4 cores and 8 threads. This means that 2 threads per core. So a core is able to handle 2 threads simultaneously. So that is known as the level of hardware concurrency. And now in this program, we are going to see that number for this particular processor. Now this Mac OS is running on Intel hardware, and we can check the specifications of the processor by clicking this Apple symbol and clicking this about this Mac menu. And here you will find the name of the processor. So basically the name of the processor is Intel i5-2400S, and it is 2.5 gigahertz Intel Core i5 processor. Now let us see how many processes it can handle simultaneously. So let me save this file. I hope that there is no spelling mistake in this. Let me clear the screen again, and yeah. So here I'm just going to say program07.cpp, and yes, there was no spelling mistake. So that was the only thing I was afraid of. That's why I made sure that you know that I am also not infallible. So if I hit enter now, it is going to show me the number of threads or processes the processor can handle at hardware level concurrently. So my guess is 4. You let me know what your guess is in the comment section. Yes. So number of threads it can handle is 4. So it is a very old processor. Today's date is 2021 and it is a processor manufactured long ago in 2011. So I told you already that this iMac is a second-hand computer that I bought from a renewed store, or a store that specializes in selling the renewed such machines. And it turned out to be a very good deal because I am able to install all the software that I need, and I'm able to create various tutorials on C, C++, Python, shell scripting, Linux commands, and many more technologies. So in case you want to watch all those videos, just subscribe to my YouTube channel, and in case you don't want to miss any videos that I'm going to upload, please hit the bell icon so that you will get the notifications on your mobile devices or whenever you are going to log in to your YouTube account from any web browser or any other device. So let us continue to an important part now. So we know now how to create multiple threads in a single program. Now we are going to create an array of threads, and it is definitely going to be very, very interesting. So let me check for a program. So here we have program05.cpp. So let me duplicate it. Let me save it to my favorite directory. In case you are wondering where you can find these programs, you can definitely find them on my GitHub repository, and the link for that is in the description section of this video. Now let us go ahead and modify this INTI. So it is just going to accept a single argument inside foo. So I will say inside thread number, I and std and l. And here I'm going to say now my threads 20, and I'll delete this part. I'll also delete this part, and we are going to write two loops in place of those statements. So here we are just creating that object. Now we have to initialize it by assigning it to the foo function. Int I equals to 0, I is less than 20, I plus plus, and I'll say my threads of I equals to std thread foo comma I. Okay, sorry, it should be I, and let me escape colon. So this is where we are assigning the function to the thread object, to the individual thread object in that array, to be very specific. Now let us go ahead and write a loop for joining all the members of array, and this is awesome. Okay, so here I'm going to say if my threads of I dot joinable, so it is going to return a boolean true or false. My threads I dot join, and I can go ahead and save this program. So here we are creating 20 threads, and each thread is accessing this particular resource std.cout and printing its number. That's it. It's a very simple program. Then we are joining all the threads. Basically these are all arrays. Okay, so these are all members of arrays, to be very specific, and this is a single array and it has got 20 members, and we are initializing all the members as threads. Now let us hope that the program compiles without any hiccups. Okay, so I think I made a small mistake, and I think that you also noticed that it is 0 not O, because that 0 and O buttons, they are near on the keyboard. It is very common for any programmer to commit that mistake. So I hope that all the viewers will forgive me for this mistake and will not hold me accountable by saying that I have committed some sort of treason. Okay, so I think that I have again forgotten a semicolon. See, basically I'm a Python programmer, and I always keep on forgetting all these semicolons when I work with C and C++. So the program compiled successfully. I will just say a dot out, and okay, so here we have the output. Now let me explain you why the output is like that. Basically it is printing this statement here, and all the threads are trying to simultaneously access that particular resource. So std colon colon cout is a resource, and all the threads are trying to acquire a lock towards it, a lock on it. Okay, and it is actually causing a lot of problem. That's why we are actually able to see all this output out of sync. Okay, now this is something what we call as a race condition in the operating system, and there is a way to deal with this race condition. So now in the next program we are just going to modify a couple of lines in this program. It is going to avoid the race condition. So now I think that you have understood the meaning of race condition. So basically this is a single resource and there are so many threads trying to access it that it is actually causing problems in proper execution of this entire sentence at once. So if this entire sentence is executed in one go, we will actually have a nice output in place of such sort of outputs. Okay, so we will make sure programmatically that it behaves correctly, and that is also quite possible. I will just say documents Ashwin data cpp mult and program 9 dot cpp, and I will save this. And there is something known as mutex. So include mutex. So mutex is nothing but mutual exclusion. So this library provides us the mechanism for creating locks, and it is actually quite easy to create locks. So we know that meaning of lock. So suppose you have your own house and you don't want anyone to access that house, you will lock that house when you are not in the house. Obviously, even your family member shouldn't be in the house, otherwise it will be illegal to lock your or detain your own siblings or parents or spouse in your own house. So whenever the entire family is going to go out, you just take the lock and put it on your door or latch, to be very specific, and then you go out so that no one else can come and access that lock and your house. And once you come back, you unlock your house and then you again carry out your activities. So I can just say std mutex m, and let us create a simple lock m dot lock, and finally, so we are now locking this resource, this particular std.cout resource, and finally m dot unlock. So we are acquiring the lock here, or we are locking this resource and then we are relinquishing that lock, or we are unlocking that stuff. So it is as simple as that. We added only 4 lines of code: the include statement, the declaration, lock and unlock, and it is going to take care of the race condition. Okay, because all the threads are looking for a single resource. So this is what we call as the race condition in operating system. Now let me go ahead and clear the screen. Let's compile it with G++. Let's change the name of the source file here. So it has compiled and let me execute it. I am keeping my fingers crossed because I am running this program very first time on macOS, and it should actually give us the correct results. Otherwise, it will be such a huge shame for me. Okay. And yes, so macOS is a very nice operating system. It is actually executing this program very well. See here, we are acquiring the lock. That's why it is flawlessly executing the entire std : cout statement, that entire resource, in a single go, and it is not actually garbling the output like earlier. Okay, so this is how we can take care of the race condition while creating the threads. We can just go ahead and use this mutex construct provided to us by the POSIX threads, and it is actually available by including this mutex in your C++ program. So let us have a small review of the entire episode. So we gotten started by writing a simple program and executing it on the command line. Then we tried the Genie editor. Genie editor was able to compile the program, but it was not able to execute it. So we switched to the Xcode, and then Xcode compiled and executed the first program. But since I don't have actually a lot of experience on this Mac OS, I was not able to execute the next program. It was actually showing the build failure. So what we did was we decided to continue using Xcode to edit our code, and then we decided to continue using the command line to run our program, to compile and run. Now the command line is a bit tedious and it is difficult to change the fonts and settings and all. So we installed a nice alternative, iTerm 2 for macOS, and we started compiling and executing program on this terminal emulator rather than the built-in terminal emulator of macOS. We still continued developing programs using Xcode because this is a very nice looking editor, but I'm just actually using it as code editor. I'm not actually considering this as an IDE because seriously there are lots of settings and all, and I prefer actually to compile the program manually and execute it. So this gives me actually finer control over all of my programs. So we can go ahead and continue using this IDE for developing the programs, and we can continue using this iTerm 2 to compile and execute all the programs. So we have seen a lot of programs. We have seen mutexes, we have seen locks, we have seen how to check the hardware concurrency and how to join the threads, how to check the process ID, and how to create threads in various ways. So I hope that you have understood all the concepts that I have explained and demonstrated in this episode. So thanks a lot for watching this episode. Do let me know if you have any questions, comments, or suggestions about anything, about the way I deliver, the way I explain the things, the way I write the code. Because just like everyone else, I am also not perfect. Perfection is a journey that we always travel towards. Okay, it's a kind of destination, and it is sort of unreachable destination. We can always keep on improving ourselves. So your precious feedback is going to help me to improve the quality of the episodes that I am uploading on my YouTube channel. And in case you find that this episode is useful to you in any way, please go ahead and share this video, like this video, and please subscribe to my YouTube channel. That is my humble request to you. Thanks a lot once again, and I will see you next time.